If you need to store key value pairs in JavaScript, your muscle memory probably reaches for the plain object literal. It's quick, it's easy, and it works most of the time. But plain objects were never really designed to be general purpose hash maps. They have prototype inheritance baggage, they implicitly convert keys to strings, and iterating over them can be clunky. In this video, we are going to master the JavaScript map. We'll look at the three major reasons why you should switch to map for dynamic collections, key flexibility, performance, and ergonomics. By the end of this tutorial, you'll know exactly when to stick with an object and when to upgrade to a map. Let's start with the basics. A map is a collection of key value pairs just like an object, but main difference is lies how we interact with it. In here you can see we have a plain object and we are adding a key and a value and we're accessing it. That's how I do it. Now let's see how map works. In the right side, you can see we have created a map. We are using its methods to add key and the value to that key, and we are using explicit method get to get the value, and there are explicit method to delete the values. Here you can see we can run the code in terminal, and you can see we have the cache object, and then we get the user and we get that value. Now you might think the object may look cleaner because of the square brackets, but objects have hidden flaws. Key stringification. Let's see with an example. Watch what happened because object keys must be string. JavaScript converted both of a user objects into string, and when you convert object into string, it just shows object. The second entry overrode the first, we lost the data. Now if you see, if we use a map instead of an array and we set the object as the key and then use that same object uh, to get the value and we can run it, you can see we have admin. And now let's see a real world use case, what we might use this feature in. We have a map and we are using the user like login counts, initializing it. And whenever we call this method, we just use that object and increase the count by one. You can see we have user one, two attempts, and user two has one attempts. One more benefit is that you can use number and string as different keys. We can run it and see in object count is user ID is user ID because this one replaced the previous value. But in case of map, you get exactly different value. So you don't have to worry about these kind of things when you can use the map. Now let's run some benchmarks and see what time takes. So we have a 2 million size and we'll create plain objects by looping through it and adding key and value, and we'll use the console.time to measure the time, and we'll do the same using map. As you can see, we have ran it, so we'll run it again, and you can see it took 871 milliseconds versus 690 milliseconds. Let's now see the random access performance. Here you can see we are generating 100 random keys. Let's run it and see what is the performance benefit. We're creating the object. Okay, now you can see object, it took 0.05, it took 0.03 millisecond in. Now let's go ahead and see the size check. In object, you normally do this Object.keys. What this does is it creates an array of the keys first, then you can look at the size, so dot length then size. But in map there is a already a property that checks the size. Now let's run it. Okay, now see, this is like a huge performance gain. It's taking 251 milliseconds for the object size check, and it just took just 0.003 milliseconds. So this is a huge performance gain. Since it first creates an array of all the keys, so this is like time complexity is O of n, but in map, this is a property, so its complexity is O of 1. Now let's come back to iteration. in object and process map. So iterating over an object is historically messy. You need for in loop and you need also check has on property so that you don't loop through its prototype properties, or you can use objected entries. Map is iterable by default. It just works with for up loops and crucially it guarantees insertion order. Let's use this simple example. So you create a map and just use the for up loop to run it. You can see we are logging key and value and it guarantees the insertion order also. Now let's check the performance of iteration in object versus map. Let's see. Okay, so it took 395 milliseconds in foreign loop and it took only 16 milliseconds. So that is like a huge performance gain to use map instead of a plain object. So does this mean you never use JavaScript objects again? Absolutely not. Objects are still the heart of JavaScript. Here is my rule of thumb when to use object, when to use map. So when you, let's say you need a simple object where you need to store username and ID and admin, use a simple object. And there is also one more thing that you cannot stringify maps correctly. So whenever you need to send some payload to the API or even you send down the payload to the UI from your Node application, use JavaScript objects because you cannot reliably like stringify maps and then parse maps. So in that case, use JavaScript objects. For map, when you have dynamic keys, when you need to know the size of the object frequently, and when you need the key to be random, like you need to, as our example, you need to use the user object as the key, then you need to use the map. To wrap it up, the map is the correct data structure for collections and dictionaries like creating hash maps in modern JavaScript. It prevents key collision bugs. It allows you to attach data to objects or DOM nodes, and it gives you a clean performance API for iteration. If you enjoyed this tutorial, I have similar video on JavaScript set. Go and look at it.